All right, I'm coming back at you with another video. We are doing exponential equations and we are transforming them into logarithmic equations. So when you do exponential expressions, you're always going to have a base, and that base is just going to be the number b. And that base is going to be taken to a power, which is called the exponent. And then the base raised to the power is going to give you the result. The result. And in this case, we'll call that x. Okay, so that's our exponential expression. And what I want to do with it is I want to change it into being a logarithmic expression. So we're going to have a logarithm. That's what the log stands for. And that base, that b, is going to instantly become the base of the logarithm. So this number down here that's written as a subscript, this is going to be the base. The result is what's going to go inside the parentheses, because the exponent is going to be taken all the way to the other side of the equal sign. So starting off with number 1, I notice that number 1 gives me 4 squared is equal to 16, or 4 to the power of 2 is equal to 16. We can make this into a logarithmic expression. So I start off with log, that's my logarithm. I know that my base is going to be 4, right? So I'm going to make that into the base of the logarithm. Now inside the parentheses, I'm going to have the result, and the result from this one was 16. So I'm going to put that on the inside. And then I write my equal sign, and on the other side of the equal sign, I'm going to have my exponent, 2. All right, so let's try number 2. Right now, we have a base of 2. So I'm going to make that the base of my logarithm. Inside the parentheses, I'm going to have my result. In this case, that's a 32. And then I have that equal to my exponent, which is 5. So the exponent is always going to go to the other side of the equal sign. Okay, let's try number 3. I have 3 to the negative 3 power is equal to 1 over 27. Now, when you ever have negative exponents, what you're going to do is you're going to write them as a positive number inside the denominator. So this is really going to be 1 over 3 to the third power. And that 3 to the third power is going to be 27. So that's why there's a 27 in the denominator. But what I want to do with this is I want to make it into a logarithmic expression. So I start off by writing log. That's my logarithm. My base is going to be a positive 3. So that's going to become the base of my logarithm. Now inside the parentheses, I'm going to have my result. In this case, we have a 1 over 27. So a 1 over 27 goes on the inside. And then on the other side, we're going to have our exponent, which in this case would be negative 3. And then number 4 is going to be the last one. E to the 0 power is equal to 1. So in this case, what is our base? Our base is E. So I'm going to have log base E. My result is a 1, so that's going to go inside the parentheses right here. So I put a 1 on the inside. And then on the other side of the equal sign, I'm going to have the exponent. In this case, it's going to be a 0. So that's going to be our logarithmic expression. We're always taking that exponent and putting it on the other side. So for this one, we have a log base E. Now a log base E is going to be a special logarithm. It's called the natural logarithm. And the way we write that is an ln. So the ln is going to stand for the natural logarithm. The natural logarithm. So how can we change this into a natural logarithm? Because if you notice, the base is going to be e. And if I ever have base e, I can make that into the natural log. So I can write this as ln of 1 is equal to 0. So just a little thing about natural logs that I like to talk about. And that is exponential to logarithmic. I hope that helps.